So we are going to start on slide 6 with linear and nonlinear card sort. So we can move all of these around so you can do linear on top, nonlinear on bottom. So the graphs are the easiest ones for determining whether they're linear or nonlinear. If it forms a straight line, it's linear. If it doesn't, it's nonlinear. So this one, if I were to connect, if I can't really see it, I'll just kind of zoom in. If I were to connect these, it makes a V. So this is definitely nonlinear.
We like make it smaller, like so that they all fit.
Yeah, and what I would really suggest is actually having like linear over here and nonlinear here. And that would help us with space. So this is definitely nonlinear. This one's linear. This one would be linear if you connect those dots. So I'm going to make it a little bigger. So connect those dots and you see that it is linear. It forms a straight line. Okay, so the graphs are easy. So what about these tables that we have here? How do we know if it's linear or nonlinear? Function or not? Yes. So let's check and make sure they're all functions. So let's look at the x's. Do the x's repeat on any of these? No, okay. So we've checked that. So now, what could we do?
No, that's this level one. It's like you have to find if it goes up by like a certain amount, like
if it constantly goes up by a certain amount, if it has a constant rate of change. So why don't we use our journal to figure that out? Let's write some stuff down. Well, let's see what we need to actually do, because I'd rather write something down than just kind of talk about it. So I'm going to write linear versus nonlinear in my journal. And then I'm going to write the first one down. And there's more than one way to do this. Y'all know in math, there's always more than one way. So we've got to figure out the way that works the best for us. So let me pull up mine. This is slide 6. So to be linear, it has to go up by a constant rate. And it also has to form a straight line whenever you graph it. So what could we do to determine if this is linear or nonlinear? We could see if it goes up by a constant rate. So we go from 0 to 2 and from 1 to 11. So how much does it go up on the x's? By 2. Okay, but what does it go up here? By 10, okay. So then what's the rate by 1? It'd be 10 over 2 because you do y over x. So that'd be 5. So then the next one, 11 to 17, what is that? That would be 6. And how much does this go up? 1. So is that going up by, that's 6 over 1, which is just 6. So that's not right. Then let's just look at this next one. 17 to 26 plus 9. And 3 to 5 plus 2. 9 over 2. That's 4.5. That's our rate. So this is nonlinear. I'm not going to write anything there. All right, let's look at the next one.
13.
So this is nonlinear. So I'm going to write it down in my journal. X, Y, 13, 7, 15, 10, 17, 13, 19, 16.
Wait, can you heat it up a little bit so I can get like the other thing?
Yeah. So what we were checking is to see if it goes up by the same amount on the Y value as from one point to a next over how much it goes up by the X value. Because they have to be related somehow. So we can't just keep them separated. We got to say if the Y goes up by 10, the X goes up by 2. So it should be consistent all the way through. Bless you. So then the next one, did y'all write that one down? So then the X goes up by 2. The Y goes up by 3. The X goes up from 15 to 17 by 2. The Y goes up from 10 to 13 by 3. 17 to 19 goes up by 2. 13 to 16 goes up by 3. So it's the same ratio of 3 over 2 each time. So if it's the same ratio each time, that's linear. We didn't have to reduce that. I guess we could, 1.5, but each time it's still the same thing, 3 over 2, 3 over 2, 3 over 2. We're seeing how Y relates to X is what we are finding. The change of Y, how much does it increase by over the change in X? That's what it really is. This little triangle means change of Y over change in X. So that one is linear. So we can keep this one over here. Okay, so we have these two. X, Y, 1, 1, 2, 4, 4, 16, 8, 64. Do what?
It's a square table.
It's a squared table. How do you know that?
Because 1 times 1 is 1, 2 times 2 is 4, 4 times 4 is 16, 8 times 8 is 16.
Yeah, so it's, if you do 1 squared, you get 1, 2 squared, you get 4, 4 squared, you get 16, 8 squared, you get 64. So you call this a squared table? Would a squared table be linear? Because is it increasing by the same amount? Remember, just like with arithmetic sequences, you're adding or subtracting by a constant. Same thing with linear. This one, you have to add or subtract by a constant. This would be plus 12 over plus 2. So that's 3 over 1, 12 over 2, which equals 6. And then what's 64 minus 16? I don't even know. What is it?
48.
I couldn't hear you.
48.
Okay, that's what I thought I heard. So that would be 48 over 4, which is 12. So this is definitely not linear. This is one of those geometric, is it a geometric sequence? Yeah. Yeah. Because it'd be like y equals whatever x is squared. This is actually what they call exponential. And we're not going to learn about exponential till around spring break. So this is nonlinear. So let's go and do our last one. 2, 5, 6, 10, 14, 20. So to go from 2 to 6 plus 4. For linear, we're always looking for the addition or subtraction. 5 to 10 plus 5, so it's 504. What about 10 to 20 plus 10? 6 to 14. And so that's 5 over 8 and 5 over 4 and 10 over 8. If we reduce 10 over 8, we get 5 over 4. So if it's the same, then that is linear. Bless you. So remember, you're doing the change, what it's changing from y over change of x. That little triangle is called delta, and it's change. It's kind of like slope. Well, we are finding slope, really. We're finding the constant rate of change. That's what we're doing. Okay, so this goes over here. All right, are we good? Good to go? All right, slope. Type everything you know about slope of a line. So let's do a text box. What do we know about slope of a line? I'm going to start calling on people. Okay, so if you say y equals mx plus b, what is slope in that? Okay, plus b. Oh, I need to make this bigger. Y equals mx plus b. M is the slope. Okay, so that's one. I'm going to do a little backdraw. Okay, what else can we write about slope? How do we describe it? What's it called?
Rise over road.
Oh, rise. How can I do that? Overrun? Like this? And then do a little line? What do y'all think? And then draw ourselves a line. I'm going to make that line a little thicker. Mm-hmm. Yep. So I think it's a symbol, but we can do a little triangle. Change of y over change of x. Let's make this bigger though. And I'm going to use this little line. Yeah. So the little triangle is called delta, like I was saying earlier, and that means change. Change of y over change in x. Okay, what else? Let's do some words. How do we describe slope? What's the definition? What is it? Okay. What does slope describe? What did you say? Increase or decrease? If I think about on a mountain, what is slope? If it's a, so there are different kinds of slopes. There's a flat slope and then a really inclined slope. What does slope describe? Increase or decrease? Let's say the steepness of a line. Okay, I'm looking for one more thing about slope. What's another word for slope? Or a phrase, I guess. Yeah, rate of change. That's it. That's what I'm looking for. Okay, we're going to do one more thing on here. We are going to search for an image by the web. And we are going to search for slope formula. SpongeBob, did it say SpongeBob? So formula for 2 points. Well, let's see if we can come up with, why is there not any good? What is the slope formula for 2 points? Okay, this was not a very good search, apparently. Anybody type in anything that actually gives us the formula? Sometimes this works, sometimes it doesn't. I want the slope formula. Oh. No.
I just looked it up online.
Okay, and can you copy it?
You can just like move it with your like drive it.
Okay, so how can we, oh, we can copy image? Okay, all right. All right, there we go. That'll work.
Hold up. What did you search up?
What did I search up? Slope formula?
What is the slope formula?
And then I just right click and click copy image. Thank you for that.
You have to click with 2 fingers.
I used a different one so that it says
unable to
create 2 images.
Maybe go over to images and try that way.
One word.
If it doesn't work, you might have to just type it out. Sorry, I don't know why.
Yes.
What? No, I don't. Is everybody able to get something?
1 second.
Okay. I'll wait for a second.
They won't let me like use the one that's online, but I can't find one online. Like the one that you search up. Go back. No, wait. Missy Bucket, this one work? Whoa.
Yep. I think so. Did you get it?
Yes.
Oh, good. Once you finish that, move on to slide 8. Types of slope. So we have positive and we have negative slope. Okay, what do you think when you say these words? Positive slope.
It's going up.
Going up. What'd you say?
Going up.
Going up. Okay. So we need to draw what a positive slope looks like. Use the line tool to draw it. So a positive slope, we're going to have arrows on both sides, right? So it's going to go increase from left to right. Before you let this line go, I want you to make sure it has 2 arrows. So see how you have the line start, line end? For linear functions, we have arrows on both sides. So make sure that these are both arrows.
You just like go to those little 2
Make it thicker, go over here, line weight, and let's make it a 4. And then we can also change the color by doing line color. So there is a positive slope. And now we can just copy and paste that and change it. So Control C, Control V, 3 times. Because we're going to have to use one here, here, and over there. But we need to change them so it's the right kind of slope. Do you remember Slope Dude? Slope Dude? Puff, puff, positive. Nice, nice, negative. Do you remember that at all? Really? Oh, I'm going to enlighten you.
Lovely. Did y'all see that? Whoa.
I swear this is bad. Oh my gosh.
Oh, I remember it now. I know, I don't remember.
Miss Price showed you this.
Did it show on? I don't think I was here when they were there.
Okay. It's kind of boring. Beware.
Welcome to the Adventures of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him.
Oh,
He'll
it's gonna be
teach
a
us
song.
some important
No,
aspects
no
of slope.
song.
This is the course he's skiing today. What he says will teach us about slope. Always remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain, but now he can look forward to the downhill. On the way down the mountain, he says, nice, negative, nice, negative, nice, negative. And now, after the downhill, he's in for the hardest part of the ski route, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun.
This sounds like a child record.
As he finishes the flat part, he doesn't see well ahead. And all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that is straight down, and so frightened is he that he says the worst curse word possible in math and in algebra. Undefined.
Do y'all
This is
remember
from The
this?
Adventure of Slope Dude. Remember always what he said during his ski trip.
Puff positive. Puff, puff positive.
Up the hill or up the slope, he said, puff, puff, pause it for us. He said, this
Nice,
is
nice,
zero
negative.
fun.
0 fun. And then he
And
falls
finally,
off the cliff. And what
When
does he
went over
say?
the vertical cliff and straight down, he yelled the worst curse word of math and algebra. Undefined. The uphills.
Okay, so that was fun.
I bet you don't even have fun.
Yeah, we're making Sadie watch it too. All right, so negative slope looks like, I need to switch this around.
How did you do that? Just like
I pulled a corner, and you can go any way you want. Woo!
So weird.
Thank you, thank you. I pride myself on that. All right, so we are going to write in here real quick about positive slope of puff positive. Hey, I told you it was going to be a little lame, but
I thought it was so fun, Mrs. Sausage.
oh,
I was kind of
good.
excited.
Suck
when I
up.
gave you a
Suck
sample.
up. Suck
She
up.
doesn't like you anyway. Oh,
Hey,
Suck up. That's
calm down. All right, so puff puff positive, and so we are going to say it rises from left to right. Okay, let me see if I can fix that.
sorry.
Can you see it better now?
Yeah. Come on, guys. Oh my gosh,
Good
Good
job,
job,
Lily.
Okay, so rises from left to right is our positive. All right, let's do our negative slope.
Are you trying to make it look like Halloween?
No.
Oh, well, I was at Halloween though. I wasn't. Well, wait. It didn't come to me about Halloween. No, me either.
Nice, nice, negative.
No.
No, negative.
No.
No.
I'm gonna remember that just from like how strange it was.
Yes.
Like, it was just like weird.
And so with the negative slope, it's going to fall from left to right. So instead of rising, it's falling. All right. Next is our zero slope. It is going to be 0 fun. This is 0 fun. This is 0 fun.
That guy started
Okay.
more bored than any of us watching.
Yeah, he did sound really bored. Okay, so 0 fun.
Wait, so can the zero go anywhere? Like
Yeah,
straight?
anywhere. He makes it sound like 0 fun too. So 0 fun, and what kind of line is it?
Great.
Straight, but horizontal. There we go. There we go.
Like the difference between horizontal and vertical.
Horizon. The sun comes
Yeah.
up over the horizon.
That's how I remember it. It does? I
Yes.
did not know that's where that word came from.
Yeah.
Okay. Wow. I just can't remember.
Sound like a goat.
All right, and then undefined. What is he doing? He's falling off the cliff.
It's gonna go okay.
It's gonna be what kind of line? Vertical. There we go.
Me next.
Okay, so we're gonna say undefined.
I'm the only one who understood that.
The only one who is listening.
I don't know why.
Slope, dude, falls off the cliff.
I mean,
Teddy, I need you to move your head now. I don't like sitting in the front just for this reason. I'm in people's way.
And this is a vertical line.
Maybe you have something in your hair. Like that's what they look at. Well, is there anything in my hair? Yeah.
way to make your
Oh,
own
a bird.
A bird?
Yeah.
Okay, that's kind of cool. Though.
She called your hair a bird's nest.
Oh, I didn't.
My hair is actually very brushed today. I brushed it a lot. Thank you.
All right. So, did y'all get this?
I do.
Hopefully, you got it down. So, we have puff, puff, positive, rising from left to right. So, just like we read books and sentences, we read from left to right. We're going to read graphs from left to right. So, positive, going from left to right. Negative, going down from left to right. Zero fun, zero slope is a horizontal line. Undefined is falling off the cliff. You got a vertical line. And these lines can be anywhere as long as they have the same slope or steepness. The negative could be like this, right? As long as it is going downhill. As long as it's not straight. Or it could be not very steep. All right? But the horizontal and vertical, they can just be anywhere within the graph.
Why does this circle?
Because it's showing you where my mouse is.
They can still hear us, can't they? Like, aren't you still recording?
Yes.
It's just Sadie.
Oh, yeah.
Okay, so let's look at our next slide. Finding slope from a graph. Y'all said y'all are pretty good on this. So it says identify two lattice points on a line. What do y'all think a lattice point is?
Like
Kind of
one
like
point.
latitude, so I'm assuming it's going like.
Where it crosses like perfectly. It's not a decimal or anything like that. So let me zoom in.
Okay.
So a lattice point would be, this is a point that it goes exactly through. And this looks like a point we can go exactly through. This is not. See how it doesn't cross the grid lines exactly? So you want two lattice points, a point that crosses the grid lines. So let's see what else would be
Out there.
point. Do what? That one looks pretty perfect.
1, 2.
At number one.
Right there.
It looks a little below. See how it's more in this corner than right through the middle?
The one under it kind of stays wrong.
Oh, yeah.
This one goes through exactly.
Yeah.
This one is a little below, even more below, even more below. Now above.
This one goes through exactly too.
Let me see.
It's okay. Right
We're at
here.
Read smart.
right here. Yep. So those would be your lattice points.
Which is points that are exactly on the grid.
Yes, on the exactly on the grid lines.
What? Wait, those are called lattices?
It's just called a lattice point. You can find any point.
Somebody's about to call it a lattice point.
Lattice.
It's gonna happen.
Starting with the point furthest to the left, count the number of units blank you need to move to get to the second point.
Wait, so what do you
Whenever you do slope, do you count left and right or up or down first? Think about slope. What is slope? Rise over run.
Left.
So you count rise. What would be your rise? Yeah, up and down. I'm going to pull these guys over here. Count up or down. Count the number of units up or down you need to move to get to the second point. And this is called our rise. You're filling in the blank by dragging and dropping. After counting the rise, count the number of units needed to move left and right. to arrive at the second point. And this is called, if you go left and right, that's called your run.
Are we supposed to have like a few left over?
I'm not sure. We'll see. Write the slope as a fraction. Rise over run. And simplify if necessary. Okay. Let's look at our first example. What is the type of slope?
Positive.
It's positive. Do we have? I don't think we have anything like that, do we? No. That's for 1 through 4. So it's going to be positive because it's increasing. So let's just write a text box. Positive. Now draw the slope with the line tool. The rise should be green and the run should be blue. So we need to use our lattice point. So grab us a line, and we're going to make this line for rise. It's going to be green. So we are going to start at this point because this is a lattice point. You'll see where my cursor is. It's at 0, 1. How much does it need to go up to get to the next point? Or what does it need to go up to?
6.
6. Okay, we're going to change this to green and also darken it up. So we're rising and then we're going to run. But let's write down how much did it rise? It went, so we start here and then we count 1, 2, 3, 4, 5. I'm gonna make that green. So rise 5. And now we are going to make another line for our run. So we start it where the rise ended, and we're going to run over to the next point. And it said the run should be blue. So we're going to change that to blue, darken it up. And then let's count how many we moved. Right. So 1, 2, 3, 4, 5, 6. And if we were to do this again, I'm going to show y'all something really cool because we can do it on the computer like this. Select your green line, push shift, and select your blue line.
Wait, can you say that again?
Click on your green line, push shift, click on your blue line. Okay. Right click. I want to group them together.
What did you just do?
Hold down the 2 fingers and hit group.
I didn't do that. No, it doesn't have to.
It doesn't have that?
No. No, man. Ours is back, forward, reload, save as, cast, translate.
Okay. So let's select our line again. Push shift, select our blue line. Hit Control C and Control V. And then,
Who did it?
Oh wait, what?
Mine had grid. What the world?
and then you're going to move this down
Oh.
and show that if you do a rise and run here, you also do a rise run here.
It's like I did something, but it's not.
Because two things aren't selected, that's why.
Oh, that's cool.
Click.
So all you really need to do is use these same lines. So select a line, copy it, paste it, and you should be able to move it down. And then select the horizontal line, copy and paste it, and you should be able to move it down.
Oh no, what I did.
So see how the slope is the exact same? We can use the exact same lines, distance, and everything. Okay, so rise and run. So what is our slope on this one? What's the rise?
5 over 6.
5 over 6. How can I make this into a fraction?
You press divide, and it should like.
Yeah. Press divide, put the 6 there, and then
It
press
should
enter.
like change the grade.
You have to press enter.
Wait, what? 5
The
divide.
slash
Or
sign,
space.
right?
Slash.
5?
Slash 6, and then press space.
Enter.
Oh, like that?
Yes.
Okay.
Wait, 5, 6. Enter.
What if I just underline this one?
Yeah, oh, that's actually a good idea.
You could do that too.
I kind of like that better.
Clicking.
It's less than what?
And it actually looks right, you know? 5 over 6 is our slope, and we know it's positive.
Oh no.
Can I stick with my space? Yeah. 5 slash 6 space. Perfect.
Good idea.
All right, so your assignment is to finish this slide and then also find the slope of lines on a worksheet.
Is that